Hello friends. In the previous session we have done maximum power transfer theorem, and for this entire module which we have covered, this will be the final topic, and after this we will be doing couple of sessions doing some problems are going to continue. Numericals we will be doing continuously. In case I am having a mood to make a video on just numericals, I will do that. That will be continuously coming. You can never, there is no end to numericals as such. Now in this today's topic we are going to deal with the star to delta and delta to star transformation. So basically star is usually represented by this symbol or this symbol. Delta, you all know, it is usually, this is the symbol of delta. So what is the star and what is this delta? Star and delta are arrangements of circuit elements. Alright, it is a way in which they are arranged. Alright, for now in this case let us take a resistor. Let us take 3 resistors actually. You need 3 resistors for this configuration, star and delta. Okay, so this is R1, R2 and R3. Okay, now what is a star connection? Basically a star connection is you take one end of each resistor and you connect them together. Okay, if you want you can ground them also, and you give, this is the star connection, and in case you want to give a voltage, you can give a voltage here. You can define voltages. So this is basically a star connection. Or let me take these resistance again. I can take the other end, alright, and I can short the other end, and if you want I can give some voltages here. So this is also a star connection. Look, this does not look very pleasing to eye. So usually sometimes star is also represented like this. This is also a star connection of elements, alright, or the star is also represented like this. If I ground this, all these things will be, it need not be grounded also, right? This is not to be grounded. It is not a must that these things should be grounded, but I'm just putting it because you will be finding these grounds throughout electrical engineering. Alright, electrical engineers are, star delta is very important for electrical engineers as such, even though in electronics also these topics might pop up here and there, but for electrical engineers star delta identification is very important, especially in power systems and all. So this is basically star. Now if I want to define it in such another way, for example, I am having a start and finish for these things. Start and finish. Especially in electrical machines, when you are having windings, this definition will be important. If I connect all the starts together, or if I connect all the finish of the circuit element together, I will get a star connection. Alright, so here also this is start, finish, this is start, finish. I have connected all the finish together, or I can connect all the starts also together. Okay, basically you take one point and you connect them together, then you get your star connection. Now, so this is the star connection. Let us see what is a delta connection. A delta connection is usually represented like this. Okay, this is usually the representation of delta. So R1, R2, R3, and here you can apply your V1, V2 and your V3. Delta is very simple because however you rotate it, delta is going to look the same. But another definition, or you might also find delta circuits like this, especially in electrical engineering. So this is your start, this finish, this is also your start and this is your finish, and this is your start and this finish. Now in delta, what you do, to make a delta connection, you take the finish and you connect to the start. You take the finish, you connect to the start, you take the finish and you connect to the start. And you can apply your voltage V1, V2 and V3 here. So this is also identification of star and delta. Usually in circuit analysis, we will be seeing mostly connections like this. Okay, this can be a star connection, this can be a delta connection. Alright, in some cases star can also be represented like this. They might represent star connections like this also. Alright, so this is also a star connection. Anyway, as you do problems, we will be identifying it much better. Let us do 2 problems and we'll conclude this topic. Alright, so let us take the first problem. Now that we have seen what is a star connection and what is a delta connection, you have to actually understand how to do this transformation. So let us take a star connection first. All right, so let me draw a star connection. Okay, so this is my R1, this is my R2, and this is my R3. This can be numbered in any way. All right, it is not a must that this should be R2, this can be R1, this can be R2, and this can be R3. Identification of concept is the important. Now clearly, if I put a resistance here like this across R1 and R2, I'll call it RA. Another resistance here, this I'll call it RB. Another resistance here, which I call RC. Clearly, this RA, RB, and RC are having a delta connection, and R1, R2, and R3 are having a star connection. So I'm going to do a star to delta conversion. Okay. Now I'm not going to do the derivation. The derivation you can see the textbook, and you can learn on your own, because we are going to need the results actually. Now to replace this R1, R2, R3 star network by a delta network, which is composed of RA, RB, and RC, the value of RA will be equal to, okay, look at carefully. You see, you are going to replace R1 and R2 by this RA, right? So you take R1 and R2 and you add them. So R1 plus R2. Okay. Then plus, you multiply these two, R1 and R2, and you divide it by the third arm. This is R3. Similar ways, if you want to find the value of RB, this is the RB. So you find the two arms. This is R2 and R3, right? R2 plus R3 plus R2 into R3 divided by R1. R2, R1, that can change also. Alright, when we do a numerical, it will be clear. RC will be equal to R1 plus R3 plus R1 into R3 divided by R2. Alright, so that's well and good. Now, for example, we are having a delta connection. So the given connection is a delta connection, and you have to convert it into a star connection. Alright, so the same circuit I am drawing RA, RC, and this is RB, and I have to replace it with a star connection. So look at how this comes. So the replacement will look like this. All right, so this is going to be my R1, this is going to be R2, and this is going to be R3. So I'm given the value of RA, RB, and RC. How to find R1 and R2 and R3? So R1 will be equal to, take the two arms RA and RC, multiply them together, RA into RC divided by the total RA plus RB plus RC. You can just memorize this. Next is R2 will be equal to RA into RB, RA into RB. See, R2 is in between RA and RB, right? So RA into RB divided by RA plus RB plus RC. Okay. And R3 will be equal to, R3 is between RB and RC. So RB into RC divided by RA plus RB plus RC. The deltas to star conversion is very easy to remember. You might take a little bit effort to remember the star to delta conversion. Anyway, when we do a simple problem, it will come very easily to you. Now, alright, this is the simple problem which I have taken here. Now, clearly, to find the R Thevenin, you will not be able to find this directly, right? Because there is no series and parallel combination as such in this circuit. But what you can do is that you can identify that on top here you are having a delta. Basically, these star delta problems, you should have a lot of practice. You should be able to understand, if I convert a delta to star or a star to delta, what is the advantage that I'm going to get? All right. So let us just do this problem now. Okay. So if I convert 1, 3, and 4, which are in delta configuration, I'll be getting 3 new resistances like this, right? In the star configuration. Due to the lack of space, I'm just putting it like this. All right. Now, once you do this, in your mind, you can see that if a current flows here, it will come here directly. So this particular resistance and this resistance will become in series. So let us see that now. Actually, let's draw the circuit and see. Okay. Okay. So first resistance will be this one. I'll find the value later. And the second resistance will be this one. And the third resistance will be this one. And this 3 ohm is gone because I have replaced it by the star network. And now this is the remaining network which I have not touched here. Okay. You need practice to find the star, use star delta. Okay. What will be this value now? This particular resistance value will be equal to 1 into 4 divided by 1 plus 4 plus 3, which is equal to 1 divided by 2. Okay. And what will be this resistance value here? This one will be equal to 4 into 3 divided by 1 plus 4 plus 3, which is equal to uh, this is equal to 12 divided by 8. Okay, this is equal to 12 divided by 8. Okay, so this will be equal to 3 divided by 2. Yeah, and this particular resistance here, which is this resistance and this resistance are same, so it will be 1 into 3, 1 into 3 divided by 8, which is equal to 3 by 8. Okay, and the rest of the resistance are 2 ohms and 5 ohms. Okay, now what you can see, these two resistance are series and these two resistance are in series, and in effect these two will become in parallel. So if I replace this now, okay, this is 1 by 2, this is my RTH. 3 by 8 is in series with 2 ohms, so you effective resistance will be 3 by 8 plus 2, which is equal to 19 by 8 ohms. Okay, and this 3 by 2 is in series with 5, so you will get 13 by 2 ohms, and these two are in parallel to each other, which is series to this 1 by 2 ohm. So RTH will be equal to 1 by 2 in series with 19 by 8 parallel to 13 by 2 ohms. So I hope you understood this problem. Basically, star delta requires a lot of practice and a little bit of imagination. In case you are not good with imagining things, you can just roughly draw the circuit and just rub all these things and find actually what happens. Basically, you have to see which is advantageous, doing the star or doing the delta, which conversion is advantageous. So let's take another problem which is a little bit more complicated. Alright friends, this is the second problem which I have taken, in which you have to find the Thevenin resistance across this particular area. Now here also you don't have any direct method of solving this, therefore you have to see whether you can identify a star delta or delta star transformation which will be advantageous to us. Now when I look through this circuit, I can clearly see that there will be no direct deltas here, but I do see this is a particular star. Okay, let me just put it in another color. So this thing which I am marking, these things are in a star connection. Also this is also in a star connection, right? So I will just take this particular network first. Okay, the one which I am drawing in this red color, I will just take these three resistances 1, 2 and 3, and I'll replace with the delta connection. So when I'm replacing with the delta connection, okay, I will get one resistance in this point and this point, one resistance in this between this point and this point here and this point here, and one resistance will be between this point here and this point here, right? So let me redraw the circuit. Okay, so the first resistance will be like this. Okay, and let me just draw the remainder of the circuits. I will draw the others later. Yeah, this is the remainder of the circuit. Now one will be between this point and this point. Okay, after the star to delta, one will be like this, and the third one will be this point and this point, which is this point and this point here. So this will be the third resistance value. So what will be the values of the resistance? The first value, now this is a star to delta conversion, therefore the resistance between these two will be equal to, this will be 10 plus 10 plus 10 into 10 divided by 10. Very easy, right? So this is 30. And because all the resistance values are exactly the same, this also will be 30 ohms, this also will be 30 ohms. And this is 10, 10, 10, 10 and 10. Okay, so now you can clearly see you are having a little bit different circuit. Now all the, after doing one star conversion, everything has become a delta conversion. Okay, so now what we can do is that we can do two delta conversions here, delta to star, in which I will be getting a configuration like this. Now use this color. Yeah, I will be getting one resistance like this. If I do a delta star conversion here, one will come like this, and the other one will come like this. Okay, and if I just rub these things away, because I have done the conversion already. Okay, what I will get here after the conversion, the advantage here is that, let me just draw the resistances also here. This is a resistance here, this also is a resistance, this also will go, right? So here you are having another resistance, this is also a resistance, this is also a resistance, and this is also a resistance. So clearly these two resistances will be in series with each other, right? Okay, and these two resistances will be in series with each other. In fact, these three resistances here will be in series. This particular resistance, this resistance, and this resistance will be in series. These two will be in series and it will become a parallel connection. Okay, so let us just find these values, and I have already found out these values and I'll just put it directly here. Okay, if you do the delta star conversion, you will get here 6 2 6 here, and you'll get here 6 6 and 2. Okay, okay, now let us just combine all these things and see. So if I just redraw this circuit here once again, I will get here, this is going to be my 30 ohms. Okay, and here I am having my 6 ohms. Okay, this particular 6 ohms I am putting here, and this 2 will be in series, the 6 and the 6 is in series, so I get 12 ohms here. Yeah, and here I am having a 2 ohms, and here I am having a 10 ohms. Okay, and here I am having another 6 ohms, this will get connected here, and this is 2 ohms. All right, so what will be the effective resistance? Let us just find. So RTH will be equal to 2 plus 10 plus 12, 14, 14 parallel with 2. All right, so I'll get 2 plus 10 plus 2, which is parallel with 12. Okay, that is this particular combination here, and that will be in series with this 6 and this 6 here. Okay, so plus 6 plus 6, and this entire thing will be in parallel with the 30 ohms. Okay, so I hope you have understood this question. In case you are having any doubt, I'll be doing, you can mention in the comments below. I'll do some more problems and just explain how these star delta conversions are getting done properly. All right, I hope you have enjoyed this video today, and I will see you in the next lecture. Thank you.